Hey guys, what we're going to be talking about today is angles and all about them. What they look like, some vocabulary, how to name them, all that good stuff. So, pardon my poor drawings, but I couldn't find an online diagram I liked, so I took my shot at drawing on the PowerPoint. But this is all about how angles are named. So what you see here is I have this angle drawn out on the screen, and it has 3 points on it. It has A, B, and C. Now, to name an angle, we need all 3 points. We utilize all 3 points in its name. And we start out by drawing a tiny little angle before we actually list any of these points. So you can see that down there. It looks like a slanted L, but that actually stands for angle when we're talking geometrically. And then we put the 3 points on the angle after it. Now here's the critical part, is maybe I should have put this after one of my vocabulary slides, but this B point right here is what we call a vertex. It's where the angle meets at, right? It's kind of the origin of the angle, if you will. This B point always has to be in the center of the angle's name. Now, it doesn't matter what side you approach the B at coming from when naming it, but the B always has to be in the center. So it could be A to B to C, like our first name here, or it could be C to B to A, like our second name. Both of these say the same thing. They say angle ABC, meaning point A connects to point B and that connects to point C, or the same thing in our second diagram. All right, so let's talk about some of that vocabulary here. So we already mentioned vertex. Vertex is the point where the 2 arms of the angle meet. Now, technically, the arms of the angle, the lines going out this way and the line going out to this side, are rays, right? We talked about rays being lines that go infinitely in one direction. And that's what we have here. This line that connects B to A and then has that arrow, that's a ray. But it is also one of the arms of the angle, just like BC is a ray, but also an arm of this angle. Now, we have what we call an interior of the angle and an exterior of the angle. The interior of the angle is all of the space in between the 2 arms. So where I'm circling around with this pointer, all of that is the interior of the angle. You may sometimes hear me refer to it as something is inside the angle or something is in the angle. That means it is within the space between the 2 arms. There is also an exterior of the angle, and that exterior is all the space, you guessed it, not on the interior. So it's pretty much all of this out here. All of this is the exterior of the angle. We don't deal with exterior very much. It comes up sometimes in some more complex topics in higher level mathematics. We'll be talking about an exterior to an angle a little later on. But for the time being, all you really need to know is the exterior is this stuff on the outside. Now, the next thing I want to talk about is the actual measure of the angles. You'll see we have a protractor on the screen here. We're not going to be talking about in this video how to use a protractor, but it does bring up talking about measurement. Now, angles are measured primarily in degrees. That's what we're going to be using. There are other systems. Some cultures use gradients. A lot of higher level mathematics use something called radians, but we're going to be talking about degrees. Now, within what we traditionally think of as angles, being something that could start right here where this point C is at and go all the way around to the other side of that protractor on the screen, there's 180 degrees, right? Now, depending on how many degrees an angle is, we have a different classification for it. And that's what we're going to talk about next. We have something called acute angles. Acute angles, by definition, are greater than 0 degrees, which, I mean, just effectively means that it exists, but it's less than 90 degrees. So it's always going to be kind of closing in on itself. As you may know, 90 degrees goes straight up. It's what we call perpendicular, as the two arms would be perpendicular. So it's going to be somewhere in this smaller range, just kind of sort of open, kind of peeking into the angle, if you will. Now we have right angles, as we mentioned a moment ago. Those are exactly 90 degrees. No other angle measure is right, just 90. And a lot of times whenever we have these, we denote them with this little square right here, around the vertex, but connecting the two arms. That little square means it is a 90-degree right angle. Then we have obtuse. These measure greater than 90 degrees, but less than 180. So this is a lot more open. I always think of, kind of like I said, acute angles is kind of peeking in. Obtuse angles is like all the way open. If you're reading a book, you're going to be holding it at an obtuse angle to be able to see the pages. So greater than 90, but less than 180. And finally, we have a straight line. Now, it may seem weird to include a straight line slide on an angles PowerPoint, but think about it. Technically, a straight line is an angle. It's just a 180-degree angle. If an angle started here, went all the way around there, all the way around that protractor like we were seeing before, that's a full angle. That's 180 degrees, but it is just a straight line. So that's kind of what I wanted to talk about today. Just some of that fundamental angle vocabulary. We'll be talking in some future videos about using angles together, some additional vocabulary when we talk about actually solving angles, doing that kind of stuff. But I just wanted to do an overall introduction to them here. So if you have any questions about this, or anything you need to see worked out or defined, I guess, feel free to drop them in the comments below. Otherwise, I will see you guys next time. Thanks for watching.